Go to the Analysis tab. Build Model Check. The Building Model Check will check for possible modeling errors or mistakes. Since we have already run this process, we will not repeat it. Perform Eigenvalue Analysis. An eigenvalue analysis can be performed as part of the building analysis in order to calculate natural frequencies and mode shapes. This will be dependent on story mass and model stiffness. No loading is used in the analysis. The eigenvalue analysis results can then be used for seismic design purposes and can also be of value if wind tunnel tests are required. Display analytical model before analysis. If this option is checked, the analytical model will be produced and shown before proceeding to analysis of the forces on members. This option is very useful as a preview and pre-check if the physical model has been converted correctly to analytical model. Refresh the connectivity information of all members. Default is checked to ensure member connectivity information is updated before analysis. Save foundation column wall results for multi-block combined foundation design. This is only required when this project will be imported by another project for combined foundation design. Click Building Analysis. The Batch Design Options dialog will appear. It allows you to perform the design of column, wall and beams automatically after the analysis. We advise this should only be done if you have checked the analysis result thoroughly, otherwise the design may be meaningless if the analysis forces are erroneous. Click Building Analysis without performing any design. The analysis will start. The analysis will record the different stages of the analysis in the same dialog. The analysis will also automatically check for instability and large deformations. There may be warning messages if problems are found. When analysis is successfully completed, the messages dialog will appear, summarizing the important results and warnings, if any. Click OK to close. When the analysis is successfully completed, a green tick will appear next to the icon. The analysis date and time will also be shown, which is a very handy information to check when was the last analysis done. Once analysis is successfully completed, the axial load comparison report will be prepared. Click to view the report. The report will be launched in separate report review window. In this window, you can print and view the report with the various option at the top ribbon. You can also export the report to PDF, Microsoft Word, various image file format or web format. At the right is the notifications pane. Important messages may be displayed here. Notice that the axial load comparison report show various tables with figures for each story and sum of all stories. We will now go through this report in detail. The Axial Load Comparison Report, or ALCR, sums all of the dead and life load applied at each story and displays the axial forces in the columns and shear walls. Tables can be cross-checked against each other to verify load in equals load out. These values need to agree with each other within a default tolerance limit of 5%. A warning will give if exceeded after the analysis. A high discrepancy means there may be loads missing. This may be due to modeling errors, example unsupported columns. You should investigate thoroughly if there is any missing loads. Go back to the model to take corrective action. Rerun analysis. Recheck the ALCR report. Table 1 is the total loads based on slabs. It is the sum of applied loads on slabs, applied loads on beams and member self-weight. In short, it is the input loads based on what is modeled. You can take this as the correct ed and live load of the model, provided you have entered the loadings as intended. Table 2 is the total loads after slab load decomposition to beam. It is the sum of slab loads decomposed onto beams, other applied loads on beams and member self-weights. The slab's values are all 0 in this table, as the slab loads are calculated onto the supporting beams. Some of slabs loads are also calculated to the walls, as the walls are also supporting some slabs. Table 3 is building analysis column and wall axial loads. Axial loads of columns and walls are obtained from building analysis result. They are summed for each story. Axial loads are always accumulative, that is cumulative of the current story and all stories above it. Delta G or Q is simply the cumulative axial load of the current story minus the story above it. This is equivalent of the individual story weight. total base reaction shown should be the same the total sum of axial loads. For beam and slab model, tables 1, 2, and 3 should agree. Firstly, check sum table 2 equals table 1. If table 2 is less than table 1, slab loads are lost or missing. Compare values for each story to find out which story is the problem. Example, slabs may not be supported properly by beams. You can check on the plan view whether yield line is drawn correctly for slabs. Try using finite element load decomposition. If table 2 is more than table 1, slab load calculation is more than expected, hence conservative. However, if the difference is significant, then you should also go back to your model to investigate. Lastly, check sum of table 3 is equal or close to table 2. If table 3 is less than table 2, column and wall loads are lost. For example, beams may not be supported by columns properly, or the other way around, the columns are hanging in the air. Similarly, check values of each story to identify the culprit story. If table 3 is more than table 2, the axial loads are more than expected and hence conservative. However, if the difference is significant, then you should also go back to your model to investigate. Close the axial load comparison report window to proceed.